Hello my dear students, in this video I'm going to talk about how to change the order of integration when we are evaluating double integrals. For example, we want to find the integration of 1 with respect to y from y equals to 0 to y equals to x, and then with respect to x from x equals to 0 to x equals to 1. Basically, this double integral gives us the area of the region bounded by these four lines represented by x equals to 0, x equals to 1, y equals to 0, and y equals to x. So the straightforward way to evaluate this is integration of 1 with respect to y, so that should be y, taking the limits of integration y equals to 0 to y equals to x. Integration with respect to x remains same, x equals to 0 to x equals to 1. Applying limits of integration, that would be equals to x minus 0, so no need to write 0, that would be x. Integration with respect to x from x equals to 0 to x equals to 1. Now the integration of x with respect to x would be equals to x square divided by 2, taking the limits of integration x equals to 0 to x equals to 1. Applying the limits of integration, that would be 1 square over 2 minus 0 square over 2, so that would be 1 over 2. Geometrically, if we see that is this is x-axis, let's say this one is y-axis, they are meeting each other at origin. This one is y-axis, this is x-axis. If this point is 0 comma 1, and if this point is 1 comma 0, then this point would be 1 comma 1, and the straight line from these 2 points joining these 2 points will be the equation y equals to x, and this line would be y equals to 0. This line would be x equals to 1, and this line is x equals to 0. So the region bounded by these four lines, x equals to 0, x equals to 1, y equals to 0, and y equals to x, is this triangle. As we have already discussed this example in the previous video, that the area of this triangle can be found by using double integral by finding the double integral of integration of 1 from y equals to 0 to y equals to x, means from bottom to top integration along the vertical direction, and then from x equals to 0 to x equals to 1 along horizontal direction from left to right. Now this was one of the way to evaluate this integral, and the answer which we have obtained is 1 upon 2. But for example, if we are not happy with this order of integration, for example, we are not happy to integrate this integral with respect to y first, we want to integrate with respect to x first, then what we have to do? We have to change the order of integration. We have to take these limits of integration switched along these positions. So we have to take this x limits on this side and take y limits on this side. So what we have to do? We have to now change these lines. First we are taking the x limits from left to right. Now we need to take these straight lines. We need to take these straight lines from bottom to top. So we can consider this as one of the y limits. We can consider this line as another y limits. What would be the equation of this straight line? That would be y equals to 1, because we know that the coordinates of this point is 1 comma 1. So the equation of this straight line would be y is equals to 1. What are other two straight lines? Other two straight lines are, one of the straight line is this one. Okay, let me choose another color. Okay, let me choose this one. So one of the lines is this one, and now we are choosing this one and this one. Okay. Now this is the direction in the x direction. This will be in the x direction, and we will be taking this in the y direction, right? So now we will write this is y equals to x. So instead of y equals to x, instead of taking value of y, now we are taking value of x. So we will write x is equals to y. Hence we can write the integral as y is equals to 0 to y is equals to 1, integration with respect to y, but we want to integrate with respect to x first. So with respect to x here, and then taking the limits of integration with respect to x, which is from left to right. So that should be x is equals to y to x is equals to 1, and the integrand should be equals to 1. So this is how we change the order of integration. Okay, let's check whether this works or not, whether we are getting same result or not. So we will evaluate this integration with respect to x first. So integration of 1 with respect to x would be x, taking the limits of integration, x is equals to y to x is equals to 1. Integration with respect to y remains same, y is equals to 0 to y is equals to 1. Okay, then taking the limits of integration, applying limits of integration, that would be 1 minus y, then limits of integration with respect to y, y is equals to 0 to y is equals to 1. Now the integration of 1 minus y with respect to y would be equals to y minus y square over 2. Taking the limits of integration of y, y is equals to 0 to y is equals to 1. So applying the limits of integration, what would be that? That would be 1 minus 1 square over 2 minus 0 plus 0 square over 2. Solving this, we will get 1 minus 1 over 2, which is basically equals to 1 over 2. Hence that gives us the same answer as we obtained using the double integrals when we evaluated this double integration with respect to y first and then with respect to x. So whenever we are not very much happy with the order of integration, then we can change the order of integration, but we must be very much careful about these limits of integration. The constant limits of integration should be evaluated at the last, right? So we have to figure out that what are those boundaries. The limits of integration along x-axis should be from left to right, and the limits of integration performed along y-axis should be from bottom to top. So this is the main point which you have to be very careful. This is a very simple example, that's why we don't feel any difficulty in changing the order of integration, but sometimes it is quite difficult when the geometry, when the region geometry is very complex. Let's take one more example and try to understand it further. Okay, let's say we want to integrate the double integral. Let's say y is equals to 0 to y is equals to x square. Integrand is 1 with respect to y, and then with respect to x from from x is equals to 0 to x is equals to 1. The double integral is same, just I have changed this value. Instead of y is equals to x, now I am using y is equals to x square. Let's try to plot this region bounded by these limits of integration. This is x-axis, this one is y-axis, right? Okay, let me choose the white color. All right, so this would be x is equals to 0, x is equals to 1. So x is equals to 0 will be along this y-axis, x is equals to 1. For example, this point is 1 comma 0. So any line parallel to y-axis passing through this point is x is equals to 1. So and y is equals to 0 is this x-axis. Y is equals to x square is basically the parabola. So parabola should pass through 0 comma 0, and it also passes through the point 1 comma 1, and it is something like this curve, and this is the equation y is equals to x square. Hence the region bounded by y is equals to 0, y is equals to x square, x is equals to 0, and x is equals to 1 is this region. Sorry, x is equals to 1 is this region. Right? So we can solve it very easily. Integrate with respect to y, apply limits of integration from 0 to x square, then the result should be integrated with respect to x, apply limits of integration from 0 to 1. But if we are not happy with this order of integration, for example, we want to integrate with respect to x first and then with respect to y, what we have to do? We have to change the order of integration. Now instead of these straight lines, constant limit of integration, straight lines parallel to y-axis, now we will take the limits of integration, the straight lines parallel to x-axis. So we will consider the first straight line as this straight line parallel to x-axis, another straight line parallel to x-axis would be this straight line. The first straight line here, its equation is y is equals to 0, this one is y is equals to 1. Now we have already figured out these two constant limit of integration from bottom to top, from 0 to 1. Now we are concerned about the limits of integration in horizontal direction. Horizontal direction should be from left to right. Since we are concerned about this shaded region, so we have to move from this line to this vertical line, right? Vertical line, we already know that it is equals to x is equals to 1. But what about this line? We know that this is y is equals to x square. What should be the value of x in terms of y? So that should be x is equals to square root of y. So the limits of integration in this direction would be from x is equals to square root of y to x is equals to 1, and then integration with respect to y will be from 0 to y is equals to 1. Hence this double integral can also be written as the integration of 1, now with respect to x first, from x is equals to square root of y to x is equals to 1, then with respect to y from y is equals to 0 to y is equals to 1. We can prove this very easily. Let's solve this this integral first. Okay, so the integration of 1 with respect to x would be x. Applying the limits of integration, we will get 1 minus square root of y. And then this is y is equals to 0 to y is equals to 1. If you are not good at evaluating these integrals, you have to watch my previous videos. So I'm just skipping that procedure because we have already done it in previous videos. Now the integration with respect to y would give us y minus y power 3 over 2 divided by 3 over 2. Taking the limits of integration, y is equals to 0 to y is equals to 1. Now when we apply these limits of integration, that would be 1 minus 1 over 3 over 2. But when we solve this, that would be 2 over 3 here, and when we resolve this, that should be 1 over 3. Now this is the answer of the integration of 1 with respect to x first and then with respect to y. Now let's try to solve the integration with respect to y first and then with respect to x. That would be equals to integration of 1 with respect to y, that would be y, applying the limits of integration, that would be x square, right, and then integration with respect to x from x is equals to 0 to x is equals to 1. Integration of x square with respect to x, that would be x cube over 3, taking the limits of integration, x is equals to 0 to x is equals to 1, applying the limits of integration, 1 cubed over 3 minus 0 cubed over 3, hence the answer is 1 over 3. So you can see that we are getting the same result because the geometry did not change. We have already changed the order of integration with respect to y first and then with respect to x. The answer is 1 upon 3. Change the order of integration with respect to x first and then with respect to y. The answer remains same, 1 upon 3. So whenever we want to change the order of integration, we must be very much careful that two of the limits must be constant limits and that should be evaluated at last. The other two limits should be function of some variable x or y. The limits of integration along x-axis should be from left to right, and the limits in the integration performed along y-axis should be from bottom to top. I hope that this video will be very useful for you. If you have any questions regarding this tutorial or related questions, you may ask me in the comments section. I'll be trying my best to solve your queries. Thank you very much.